as said, my presentation is about consumer-driven contract testing and why I believe consumers should be first and APIs second, contrary to popular belief that API should be first. So who am I? I'm Gerwin Vaatstra. I've worked for Capgemini for more than 7 years now. I started with manual testing, then on to test automation, lead for web development, and DevOps tester, and now I was a quality specialist for different customers. And what I really like to do is to strive to facilitate, to perform. So I don't want to be the only one that tests. I don't want to be the only one that knows how to test. I actually want to work with the team to deliver a lot of value. And by doing what I do best is focus on quality, focus on value, and focus on how we can work together. My passion is knowledge sharing, and therefore I like to give presentations, but also give trainings for the Capgemini Academy. And also I like to build a community around knowledge sharing and also help each other out. So it's a broad area that we work in, and there are so many specialties that it will be awesome if we can just help each other out and benefit from each other. Sometimes I have a bit of issues with dealing with impediments. Generally, I'm more enthusiastic about the quality than developers, but contract testing is an area where that can be less, but also can be an area where developers say, nah, I'm not sure this is the right way to go. So that makes it interesting. So what are my experiences with contract testing? It started with a client a few years ago, and they said, well, it's interesting, but I think we shouldn't do it. I tried to convince the developers a few times. Was part of the lead developers talks that we had every week or 2 weeks. And every time I went there, I convinced developers, but then came back and another developer said, well, I'm not really sure. At the end, we decided to do it. And then when we had to take it in sprint, my team said, well, I think we shouldn't do it. So then another client that I worked said, well, it's interesting indeed, but let's do it when we finish the services and the APIs are final. So they did see that it could have value, but they saw it as an overhead while developing new functionality. And also, I've been to a few DevOps meetups that talked about microservices architectures. There are a few good series on that. And a few times I heard companies or developers talk about how they had everything in place, like infrastructure as code, a full CI/CD pipeline, a lot of automatic testing. And I heard two people separately say, we have everything in place, and there's one thing that we're not really sure about is like contract testing, and we're really curious about real-time real-world experiences with that. So there was a lot of talking about it, but there was not that much experience in contract testing. So what I want to do in this presentation is to first elaborate on what contract testing is, then when and what to test, the difference between consumer versus provider-driven testing, also API design, also contract testing, the development process, how does it fit in CI/CD development, some last remarks, and if time let me, then I will show a few code examples to illustrate what it is. But this presentation is mostly focused on the concept and mostly focused on why and when you should do it instead of the code examples. So my definition of contract testing is obviously taken from a few other definitions, is that the use of verified mocks and drivers, which contracts are specified by example in code for integration of two applications and which verifies the syntax of interactions. So important point here is that it's verified, and I will come back to that later. Of course, you can use mocks and drivers, but the benefit of contract testing is that it is actually verified on both sides. And the contracts are specified by example, in contrary to many clients where I saw that they they document it on a wiki, for example, Confluence. Here it is actually specified in code by example. And it's interaction between two applications, but it focuses on the syntax of interactions and not as much on the data. All this comes back in the presentation. So integration testing and use of mocks. So if we do integration testing, you have a consumer and a provider, and there's a real interaction. If you use mocks, you actually say, well, let's put something in place, and that verifies as a driver or as a mock. In this case, actually, it's more like a driver. But it does not verify the response if it fits. If we look at contract testing, you still have obviously your actual interaction, but that actual interaction is saved in a contract, and that contract is replayed at the provider. In this case, again, as a driver. So, where in the previous example, you build a mock and you say, well, this is how it should. This is the message it should send to the provider, and the provider can test itself. In this case, it is verified on both sides, because on the consumer side, you verify that you get the actual response, and that actual response is verified on the provider if it is actually sending that response. So where's contract testing in the pyramid? I believe everybody is familiar with the testing pyramid. And I would say it's between unit testing and integration testing, and it's not as much as a separate layer as it is integration, as it is said here. It can be on the unit testing side, and it can also be more like the integration testing side. Fact is that it will take a few of your integration scenarios and will be put in contract testing, so you will get less integration tests. It does not replace integration tests, but you will get less integration tests, and on the level where it is executed, that can be different. And I have another slide about that later in this presentation. So an important law you come across is Postals Law, and it's much about API design. It's about contract testing as well. It says be liberal in what you accept and conservative in what you send. So if you put that in contract testing, you only ask what you need. So if you have a service that gives you a product, but you only need the price or and the name, for example, don't verify that your response also contains the supplier or any other information about the product. Only verify what you need, and only ask for what you need. And be losing what you reasonably can accept is actually what I explained. Except also if there's more information. If the information is there that you need, that's fine. But don't verify if it fully complies to a schema or example. For example, just verify that your information is there. So that opens up the way that if nobody's using the extra information, then the provider can actually delete that from the response without anything failing, without anything breaking. So once you establish that you want to do contract testing, and you establish that there's a benefit in that, then there's some different options on how much you want to test. So you can choose the whole service as a black box. So input-output testing of a service. That's an option. You can also test a part of the service. For example, that you receive a payload and save the data in a database, but if that would trigger an event send out or trigger anything else, you will mock that out. So it does not act as a full service, but you test a part of your service until you're confident that the payload or the response or the whatever is input can be handled by your service. You can also choose the more the purest way, I would call it. If you look online, you will find that most say this is the purest form of testing. You only test the controller of your application, the only where it enters your application. And then it can also be on the unit testing level, which is obviously a fast and reliable level of testing. In my example, in my experience, I chose the second one, the testing a part of the service. I had a Spring Boot application, and for those who are not that familiar with Spring Boot, or those who are, there was some configuration in Spring Boot that in this case, a transformation of date time. And therefore, I needed that context to be sure that I could handle that payload. So I chose to spin up the Spring Boot service and then receive the payload, see if I can save it to the database, and then stop. Why I chose to save it to the database was that I wanted to be sure that the payload that I received and was transformed to an object could actually also be saved in a database. So it was not that much more effort for the value that I was getting. And that's why I chose the second option. So my presentation also encompasses some that I should choose for provider-driven versus consumer-driven. That I would choose the consumer-driven approach. And in many cases, you see a provider-driven API design. Important to note that contract testing is only sensible when you both have the consumer and your provider in scope as an organization. For example, you cannot be an Amazon or a Google and use contract testing for the APIs that you expose, because you don't have both. You cannot really verify on both sides, because I might use a Google API, but I can say this is my contract, verify it for me, but they will probably say, well, good luck with that, but this is our API and here's our documentation. So the provider-driven approach is mostly that we say this is our service. That's mostly where developers start. This is our data model. That's also what you see a lot. And let's expose our data model as much as possible. That will result in this API. And then we tell the consumers, this is the API. This is how you use it. Here's our documentation, either in Swagger or on a wiki, for example. And you have to comply, and if you don't comply, then you have a breaking chains, and consumers just have to adapt. If you turn it around, you can also choose to start with consumers, like what do I need? What is it that I need from an API? I will write that down and deliver that contract, or actually specification more, to the provider, and they can verify if they comply. Now, that does not open the way that consumers are king in this case, because it's still a mechanism for communication. It's not that consumers dictate how an API should look. You can still say, well, we have another API, and can you use that field, for example? And then you can adapt and get a working example. There are quite some benefits in it, but I will come back to that later, how this can also benefit the development and spot mismatches or miscommunication early on. Important to note here is that the API is also aware of its consumers. If you took the provider-driven approach, mostly you're not aware of what consumers use of your API. It's possible, but mostly you're not aware. In the consumer-driven approach, you have like 5 contracts, so you exactly know who uses what of your API. So this is a practical example from a client that I had, and the client used trains. And what we had to develop was that we would get some source information about the train times, so the times train arrive at the station, leave at the station, etc. And it was also about the material, like what sort of trains, the length of the train, etc. And we would receive that from an external party, and then we would save it in a database. Then that database would send out an event if it had new information. The adapters would get the information and post it to both of the services. Maybe good to say, I was not very fond of that architecture, but that is the architecture that was chosen. Good to know. So important to note, both services had the information, and then consumers could request that information. And there was a train rights adapter in between that would combine the information from the train time service and the train material service. And there was one particular part of the information was the stop types, and that stop types included things as stop for passengers or only for personnel stop, or there was actually also a stop type that said stop for delivering of post. So there were 7 types, but the consumers only needed 4. They only needed to know if you, because it was for domestic traveling, they only needed to know, like, can I enter the train, only enter the train but not exit the train? Can I only exit the train or not enter the train? Can I both enter and exit the train at that station, or can I not enter or not exit the train on that station? And for example, sometimes you have international trains that stop at stations, and then you can only exit but not enter. And there are also stops, for example, only for personnel, where travelers are not allowed to get in or get out. So in this case, the team was responsible for showing information on the screens on the stations. Therefore, they only had those 4 options that they needed. If we have started with the consumers that they needed that, and we knew fairly well that was all the information that we needed later on in the chain as well, we could have chosen to do the transformation already early on. But because we chose the way, like, we get the information, so we save the information and we expose the information, both consumers implemented the 7 to 4 types conversion. And at the end of the project, we actually said, well, that's not nice. And we had to change both consumers, change the train rights adapter, change the train times service actually as well. So it was a lot of more work. That was the moment that I said, well, I told you so, but that was not really that they liked to hear that. But this is an example of where contract testing would have helped you with your architecture or design. So I already mentioned a few times that mostly we start with API design, that we look at our data model and see what can we expose. And then we expose a lot of information and we don't know who's using that. And we have to put extra development in keeping it working. So there were some statistics, maybe a bit older, in 2010, that in custom software development, I think 50% of functionality is hardly ever used, and 30% is infrequently used. And that's big numbers. If you also have to take into account that you want to keep that working, and you need some people to, you actually don't know who you're developing for, and therefore you develop too much. And I think contract testing can help in that way, because you know more about what is needed and can only develop what is needed. It's actually more of an agile approach, so you only develop it when you need it. So a common scenario when you have new development, when you have new functionality, that new service or new functionalities, that you discuss the requirements and you document it somewhere, especially if you have 2 teams working on the same application, or if there's an interaction between 2 applications. Then mostly you build separately, the application is not ready yet. So in integration testing phase, that both applications are somewhat ready and you could do an integration, then you will see, well, actually, I thought you would send me the date in this format. And then, well, I thought we would agree that we should send the date in another format, or we didn't document it because it was so obvious that we would send you the date in the international format or in the with an offset or without an offset. And then both teams go back to solve their own bugs, their bugs that are on their application level. And then you test again, see if it works, and then discuss where it went wrong, because there was documentation, and how come that we didn't spot it early on? Mostly because you start with the API first, and then develop, and then there can be new insights. There's also an option, new insights, new requirements, because once you're working on your application, you can see, well, maybe we can do it short. We can take a shortcut here, or we have a different need actually. So yeah, if you start with the API first, then that can happen. So if you would look at integration testing versus contract testing in this case, then from the perspective of functionality ready, in the previous example, you can only test in the integration layer when most of the functionality or a big chunk of the functionality is ready. Well, if you compare it with contract testing, you can already have the contract ready, and both sides can verify if it works, and you don't need a full-fledged application yet. For the data, for integration testing, you need a set of data that can be established, so you get the correct response. For contract testing, both sides are responsible for their own data. As you remember, maybe I said contract testing verifies the syntax of integration, not the data. So it verifies if the name field is a string of a specific value, or that it contains specific characters only, but it does not verify if it's always Tim or it's always Jack. Also, for running services, for integration testing, you need both services running, and therefore a lot of functionality and data ready, and then both services need to be running. It's a higher level of testing, more overhead, and therefore more less stable and more expensive. For contract testing, you only need your own service running, and the mocks and the drivers are handled by the framework. And lastly, what if you have dependent services? I've heard from clients that I worked for before that they had an environment where a lot of that was constantly down because dependent services were down, and therefore the environment was not usable anymore. With contract testing, you can only stop out that service, but if you use integration testing, that service might need another service and another service and another service. So that domino effect is not happening in contract testing. So if we look at software changes, then you also start with the information needs. You might change your provider. Somebody wants something else from your provider. Then you have to look into who is using your API. If you add information, that's fine. Obviously, if everybody adheres to the Postals Law, then if you add more information to your API, nobody will break. But what if you want to change the format of the address, or the format of the name, for example? That is difficult if you don't know who's using your API. So if you want to do a breaking change, everybody advocates that you should not do breaking changes. But if you need to do a breaking change, or if you want to change something because it's more efficient, then you need to communicate the new API definition to your consumers that you had to find out. maybe have two APIs in parallel. And then you also need a timeline that people switch to the new API. And in the meantime, you have to maintain both APIs, and also you have to do work afterwards to clean up the old API. And many times you find out that consumers don't have time to do the development work, and they need more time, and then you have extra communication about what you need to deprecate the old API. Not ideal, I would say. So if you take the API first approach, then you change the API and you have to adapt. And in this case, mostly you don't do that because it's a bit of harsh to say this is the new API, everybody changed now. And the breaking API change to be complete is if somebody uses it, it can break. You don't know if somebody uses it unless you research that. But so how would the workflow be with contract testing? So given that there is already a working interaction, a working integration between two services, maybe consumer one wants something new, and that might already work. So he can, for example, he gets product information already, he gets the name of the product and the price, but now he also wants the quantity. Well, maybe somebody else already wanted the quantity before, and the quantity is already in the API definition. He updates its contract, and that works fine. New contract still works, no change needed in the provider, but a new contract is delivered. So the provider knows that also this consumer one now uses quantity. But maybe it's not already there, and then the provider changes. And the provider, given that he knows he has all the contracts of all the consumers, sees that consumer 2 is working with the provider, and then that's fine. Consumer 2 has the same contract, still works with the new provider, and so both consumer 1 and 2 are happy, and the provider made a change and knows that it should work with all the consumers. But it can also be that if you change something for consumer 1, consumer 2 is not happy anymore because it might break. Then the provider is already aware of this. It's important to know. The provider is already aware of this before it goes live, before it goes to integration testing, because he already has the contracts that he can replay all the time. And then he can obviously choose two options. He can make a patch or so that both work. Or does not have to be a patch, but in this example, it was easier to illustrate. Or he can discuss changes with consumer 2, and then consumer 2 can make a new contract. Then the provider will see, okay, now both consumer 1 and 2 are working, and then go live, and then both consumers are happy. So you can never really have a breaking change if you do this correctly. It's easier said than done sometimes, but this is a kind of a good approach to never go in production and see that it fails. So we already saw the testing pyramid, and in CI/CD, obviously you test a lot of you have a lot of automatic tests, and mostly during the build phase and unit test phase, you can do that locally or on a build node, or you don't need a running application for that. And for service testing, that can be something in between sometimes. And for integration testing and end-to-end testing, you need an integrated environment where other services are present. If you compare that with contract testing can mostly be done locally as well. You don't need other services for that. Sometimes you can spin up your own service, which mostly does easy on a build slave or a separate environment. And then only the service testing is again in between. So you have more on the local side. Still, you have the integration testing phase, but there will be less scenarios there because you already know that the syntax is working. So now you maybe want to do some extra tests for security or for infrastructure or routing or maybe timing issues can not be found with contract testing. If you have a service that needs information from two other services, that can be a timing issue that you can find in integration testing, but not in contract testing. So the workflow here is illustrated with Pact flow and with a broker. And Pact flow is actually the hosted service offering of Pact. And the Pact broker itself is open source, and you can use that in your own environment, whatever you want to run. It's a Docker container, easily to run. And what a broker does, either the hosted variant or the standalone open source broker, it's nothing more than saving interactions, saving what is the request and what is the expected response, or what is the event and what is the expected result. And the broker has some extra functionality there. And for example, you can have an overview, which services has which consumers. But if we look at the stages that you go through when you develop with contract testing, then you have the build phase, you do your isolated tests, and then you generate your Pact. That will be sent to the broker, and the broker knows if this is a new contract or it's already an existing contract. It will not validate all the contracts every time again, because he knows, well, there's nothing changed, or this contract is already verified, so I don't need to verify it again. But if it needs to verify it might verify the Pact on the provider side, and that's mostly done by a webhook. So a webhook will trigger a build of the provider, and then we go to the provider side, and that provider side will mostly have a separate build phase for the contract test. So you don't need all the tests done. You only need, for example, Spring Profile to only run your contract test, and that will publish the results back, and you'll see that in 3-point publish results. And once that is done, then the consumer can resume. So in Can I Deploy, that's actually a common command line tool. They called it Can I Deploy. It will constantly query the broker, like, is the contract verified? And if it's verified and it's correctly verified, then you can deploy to test. If it is not correctly verified, then you already stop before deploying to test. So you will not demolish your test environments again. And you also see the tag, and that is, Pact uses tags. So you can say, well, this version of application A uses this version of application B, and that contract is valid. So you can have a contract that works for the test versions, but not already with the live production version, for example. So by using tags, you can see which versions work together well and which versions might not work together well yet. Well, and then after you deploy to test, integrate the test, and then you can have maybe another query again. That's in the second Can I Deploy. Does it already work for production? So yeah, then we can go to production. If it does not work for production, then we don't go to production. So that is if a consumer changes something. If you go to the provider side, they will do the isolated tests, and then they will verify all the existing contracts. They will then query it, like, is it done? Is anything new? Any new consumers that we haven't verified yet? And then they go on, just like on the consumer side. So the provider side never have to trigger a consumer, because they already know all the contracts. On the consumer side, you see that it might trigger the provider build, and that is because it's consumer driven. The consumer starts with a new contract. So if there's a new contract, then you need to trigger the provider to see if your contract is working. And there are some there are some options to store the contracts. You can store the contract at the provider side, and then in the provider repository. Then the consumers will all have their own contracts in the provider repository. If you want to do consumer-driven contract testing, then all consumers need to make a pull request, for example, at the provider, and say, well, this is my new contract, and that is an option. I would not recommend it that much, because I see more benefit in a shared repository, because then you also have more shared ownership of that, and it's easier than to have it at a provider. When you have a shared repository, you have a better overview of the interaction, and also a better place to go looking if you want to get an overview of the architecture. Both will get and push their contracts to the shared repository. The third option that I would mostly advocate for is use of a broker, because you get some extra options there. Like an overview, it's always live. You don't need to get the contract from the repository, but it's a simple API call. The Pact broker is actually using REST, so you can use a lot of functionality to update the contract, or to view who the consumers are, who the providers are. There are a lot of options in Pact for that. So a lot of information about contract testing, and then mostly there are some issues like what it is and what it is not. Like I already said, it's only when you have both provider and consumer in scope. The benefit of contract testing is that you specify a contract in code, and it is verified at the provider. If you don't have the provider in scope for your organization or for your team or most of your organization, then there's no benefit in that, because you cannot communicate. You send the contract into nothing. So only use it when you have the provider and the consumer in scope, and you can actually do something about failing contracts. Elsewhere, it's useless to see that a contract is failing if you cannot do anything about it. And it does not fully replace integration tests. It validates the syntax of integrations, but not the data. Also, integration tests have value for other things, like can service A reach service B? You cannot find that you cannot fix that in a contract test. It simply needs the whole routing, the whole architecture, whole security with tokens or SSO maybe. That needs to be done in an integrated environment by integration tests. It's not only the developer's turf. This is actually hopefully it's not new information, but this is actually rather consumer-driven, business driven. You indicate what you need from a service, and a lot of people can think about that. A product owner can think about that. A business analyst, a tester, all have some sense on what you would need from another service. And I think this is a great way to stimulate interaction between both developers, testers, and business analysts and product owners, because it is specified in code, so that's really on the developer's turf to develop it in a sensible way, but it actually says something about functionality and business value, and therefore it's not only on the developer's turf. And it's a facilitator for communication, but it's not a replacement. It's not that you publish your contract and say, this is it, deal with it. It is actually, this is our contract. And then the other party can say, well, we already have an API. Can you adjust it maybe so that it works? I've talked mostly about Spring Cloud, about Pact, and there's a second big player, and the Spring Cloud contract. I made a comparison quite some time ago, so maybe this is not all actual anymore. But these are the most of the differences between the two tools, the main differences. Spring Cloud stores the contracts at the provider side. It also chooses more of the provider-driven approach than Pact, who clearly chooses consumer-driven. Pact is better at events because it also validates a routing key. A routing key is like a tag to an event or to a message, and Pact does not validate that. So you can have an event sent with routing key A, and then it will never reach application B if it listens to a routing key B. There's a mismatch, and they would not reach each other. Like I said, Spring is more provider-driven. It is compatible with Pact contracts, but not the other way around. So if you have a Pact contract, it can be transformed to Spring contract and used, but you cannot transform Spring Cloud contracts to Pact contracts. There's no broker for Spring Cloud. Less programming languages is mainly Java. And while Pact has a lot of programming language, Java, but also JavaScript, so there's really a good way to have a front-end and a back-end validations. And of course, its integration with Spring is a lot better, but it uses WireMock compared to Pact. And Pact uses, not fully sure actually what Pact uses now. I forgot about that. So this is actually mostly my my presentation. I'm curious if there are actually questions or something that I have to elaborate on.
Yes, Gerwin, very interesting session, really. I did a lot of integration projects in my career, and there wasn't that much focus on contract testing, and that's really a shame. I think a lot of issues could be solved by focusing more on that. Great, really interesting. We have a couple of questions. Let's start with the question of Rutger. Rutger says, I understand how contract testing can work on API and on system test level, where the contracts are easily definable. But can you implement contract testing on end-to-end test level when the contracts are harder to define?
It's not meant to be implemented on an end-to-end test level, because end-to-end testing you mostly do to verify a chain of interactions. So if the question is that, for example, that you want to place an order and you want to use contract tests for that, it is actually meant to test the interaction between two services or two applications, and not a full end-to-end cycle. That would maybe comprehend you would have obviously contract tests for the different interactions, but it's not meant for end-to-end testing.
No, I understand. Okay, because you're not testing the code, the actual code and the actual function, only the contract. Yeah, I get it.
It would be the same question if you could say, can integration testing be used instead of end-to-end testing? And there are some use for end-to-end testing. Why don't you integration testing? And this is below integration testing, so no, it's not usable for end-to-end testing. Obviously, you can question if you have too many end-to-end tests, and that can be downscaled to integration test, and then you can have a look like, well, which integration tests can be used to convert to contract tests.
Okay, yeah, okay. So we have another question from Christian. He says, having front-end calling back-end, say REST API, where to handle the contract tests? On both sides?
Yeah, actually, you want to do that on both sides, because and this is actually a pretty good example. Obviously, you have a front end and a back end, and the back end is sending some response based on the front end call. That's mostly the case. So the front end will specify which call to make to the back end, and specify which response it might expect from the back end. On the back end, you want to see what are actually actual calls to the back end, and you can verify if that results in the expected result. And both can do that on their own, but they don't have to be live running simultaneously. Both can do that when they make a change to the application.
Yeah. Okay. Interesting. Okay, so that are the questions for now. Thank you very much for this session.
You're welcome.
Yeah, very interesting, and have a nice evening.
Thank you.
Thank you.